Hey, and welcome to this module in our titration video series. We're going to be covering data backup and restore, or for short, DBR. So if you have a titration cluster and you make that part of your data center, if you're using that for segmenting your workloads, if you're using it for visibility and analysis, you're going to start wondering to yourself, well, what happens during a failure scenario? How do I make sure that I have all of those policies backed up? How do I make sure that I can restore those to another cluster if needs be? And that's what we're going to be covering today. I'm Tim, and I'm joined by Remi.
Hey, Tim.
So Remi, the titration cluster itself, the actual physical appliance or the as a service of titration, both are highly available, if I'm correct.
That's right. Obviously, tasks, titration as a service. We refer to titration as a service as tasks throughout the videos, by the way. So tasks is fully redundant, fully backed up, fully everything. You don't need to care about anything. On-prem, fully redundant within a cluster, obviously. You can pull out any nodes without any notice. You won't have any problems.
Okay. So if I buy a physical version of titration, which is what data backup and restore is referring to, we only do that on the physical versions of titration. If I go up to one of the nodes in that cluster, if I pull a disk out, or if I pull a particular node out, or if I disconnect the network from one of those nodes, the system itself is already highly available, and that's not going to affect the titration cluster's operation.
That's right. I mean, we're talking, this video series really refers to a proper disaster. Okay. Not just like, oh, you know what, we just put one server, it doesn't work, let's just restore the backup.
Okay. And we're definitely not recommending that you go into your data center and start pulling servers out just to test it, but the functionality is there in the case of loss of a particular node. But when there is a serious disaster, when there is something that we really need to restore from a backup, we have the DBR functionality.
Sure, it could be, I mean, nowadays extended power outages,
yeah.
And you have to move to a different data center, or it could be fires, could be floods, that kind of stuff. That's what we're thinking about when we're talking DBR.
Yeah, I mean, we're recording this in a video studio in California, and there's, a chance that the lights might go out at any time. So you always have to think about those kind of things. So if we look at the overview of what DBR is going to provide to us, it's really about being able to take a snapshot of the titration cluster, back it up to some sort of data source, and then if there is a scenario where we need to restore it, being able to restore that to a different physical appliance somewhere else.
Okay.
So, like we see at the top here, it's a full snapshot of the cluster data. It's not just partial information, it's not just the flow data, it's not just the policy data, it is everything that cluster is required to operate, including things such as the certificates and the configuration of the software agents.
Sounds good.
So we have a snapshot of cluster data, and we'll go into some more detail around what those snapshots look like and how you can create custom snapshots if you want.
Then you talk about snapshot, and then I see a notion of state is better.
Yes.
What's up with the state thing?
Yeah, well, you really want to be able to make sure that when you restore your titration cluster, it comes back up in the same state as it was beforehand, especially when we're talking about being able to reconnect to the software agents that are deployed in your environment and have them connect back in securely and be able to pull up any new policies as we're running in the time before. This is not a stateless restoration.
Okay, so great. So we're coming back, in short, a completely identical system on the other side.
You would never know that it is not the same appliance as beforehand.
Oh, very nice. Okay.
So we have a full snapshot of the cluster. And we'll talk about how we take that snapshot and the type of storage that's required and how much storage is required. Now, that might be fine, and hopefully you'll never have an incident where you'll actually have to use your backup. But when you may have to use your backup, we've made sure that the data restoration happens in multiple stages and brings up things as fast as possible to get you up and running in the shortest time period. So that means restoring configuration around network connectivity and sensors, so those sensors can start connecting again, bringing up the policy and the segmentation rules before we get to the things like flow data and ADM data, which is less critical to have back straight away.
Okay, does that mean, because when you see a priority, I'm guessing there's something related to RPO and RTO. So RTO, recovery point objective, how much data you're okay to lose. RTO, recovery time objective, how fast should the data come back online?
Yes.
So you're talking more about RTO here?
Yes,
Okay.
exactly. We want to be able to get that cluster back up and running in as short a period as possible.
Okay. So then it comes to the question around the RPO then. How does that work out? When is the last backup that it takes?
Yeah, so we take a snapshot of the data at a time that you choose as the administrator, but typically it's a snapshot around every 24 hours. So you might want to run that cluster backup sometime during the night. So that means that your RPO might be somewhere between a few hours if you have an issue in the morning, up to 24 hours if you're just going to have an issue before that next snapshot.
Okay, I see. Seems clear.
Yeah. So let's actually walk through in a little bit more detail about what we can do with DVR.
Okay.
So we have, in this example, two sites. We have a primary site with a titration appliance, and we have a backup site with another titration appliance.
Okay. I see it seems shaded or blackish, this
Yes.
one. It's not happy?
Well, in this case, it's referring to it being a standby. The site, the backup site, the titration cluster needs to be sat there waiting to receive a restoration of that configuration. You shouldn't be using your backup site as an active cluster at the same time. It needs to be fresh and ready to deploy that configuration against.
Okay, I see. So the backup site is a powered down cluster that's put somewhere, and that's it. It was just waiting.
Yes.
Okay.
And in terms of where you might want to put that, it really comes down to you. We probably might recommend maybe having that in a different geography or somewhere else. Having it in the same data center or right next door to it might be reasonable. It depends what kind of disaster you're trying to protect against, right?
I'm guessing if you have two DCs in California, it might be a bad idea. You might need one in California, one in New York State area or something like that.
And as you remember from our session on the titration sensors, there is no requirement for them to be physically located in the same place as the titration cluster. As long as you have IP connectivity, you will be able to connect those software agents to the titration cluster. So you don't have to have it on a physical same location. So we have our primary site where our titration appliance is deployed, and what we are going to do is take a backup from that primary site.
Okay.
So we schedule an interval. What time should that interval be scheduled for?
I think we said something around 24 hours.
Yes.
You think that, that sounds reasonable to me.
Yeah, we're talking about a not insignificant amount of data, titration itself being a big data system. And in terms of when that snapshot is happening, you can choose the time period as well. So you could, do it, I would recommend sometime late at night when maybe you don't have so much activity going on in the data center.
I'd say, the usual time frame, so like 1 a.m. to 3 a.m. or something like that. Okay, sounds good.
So we take that snapshot and we take a full snapshot of the entire cluster state initially. Obviously, there is nothing configured at first, so we have to take a full snapshot of the entire cluster. And that includes all the data, the configuration data, the flow data, the ADM data, the segmentation policies. However, afterwards, we're obviously not going to take a full backup every night, and we just begin to take incremental backups after that point onwards.
Just one thing we said, the snapshot at this point, right, is totally local titration. There's nothing that moves, so I'm just saying, hey, this is my cluster, I hit the button, backup process starts, dumps a copy of the data on the same cluster, and before doing anything else.
Yes.
Okay, so that's where we are now.
Yeah, so we've prepared a snapshot, and that snapshot has all of the data. And then what we are going to do is we are going to transfer it to the array that we are going to store that backup on.
Okay.
Now we'll go into some more details around what that array looks like, but it is obviously outside of the titration cluster, and you as the end user have to provide that array.
Okay.
Finally, the array allows you to choose exactly what you're going to do on that backed up data. So if you have requirements around encryption on that data, if you want to make sure that no one could potentially read it when they get access to that array, you as the end user can choose exactly what you do with the data that's stored on that storage array.
And my understanding is that these arrays, we'll go in more details on that, but it just needs to be S3 API compatible, whatever vendor you want, that's sort of your choice. Could I go to S3 directly as well, by the way?
You could go to S3 directly if you want to. It comes down to exactly, where's the right price point for you in terms of which place you want to store the data and how local that data is to the backup site, for example. Because you have to remember, wherever that storage array is, you may need to use that to send the data to the cluster that we're restoring.
Okay, I see.
So we've put it on the storage array, and then we can also replicate that to an array somewhere else. So let's say that we have an array on the backup site that we want to copy that data to every night as well, so that there is a local copy of the backup data. That's totally permissible as well.
So in this model, what I understand is that titration backs up to a local array. So if something happens, like your row goes down, something like that, you have a local backup. So speed would be much faster to restore there. But you also cater for site failure as a whole with this recovery between sites.
Yep.
Having the data on the local site on the other side also allows much speedier recovery, I guess.
Yep, exactly. You can have a very fat pipe between the storage array and the titration cluster. So then the data is replicated over, and then these are some of the specifics about what that array actually has to look like. So like you mentioned, it is using the S3 protocol. So any type of storage array that can speak the S3 protocol is fine. You have a couple of choices up here. So obviously AWS S3 is an option. Cohesity is one that we often see people using because it is very well tested. But there is no actual requirement on what vendor you use as your storage array. As long as it speaks S3, it's going to work with us.
Okay, I'm cool with that.
Yeah. Now, capacity, that's interesting, right? So here we're saying it should have around 500 terabytes of capacity. This is a conservative number, but this is going to make sure that you would be able to take 3 complete snapshot backups of an entire fully loaded 39RU cluster, which is the largest form factor that we offer for titration.
Okay.
So 500 terabytes, maybe you might be able to go a little bit smaller if you're using a titration M. But we would recommend starting with that to make sure that you have headroom to grow if necessary.
I don't think I'd go lower than 500 even for titration M.
Okay.
Because I mean, those ones, if you want to keep 3 backups,
yeah.
I mean, you probably need that kind of capacity anyway.
Yeah, I think we should go for the recommended size.
Yeah, I'm with you on that.
So then we also would say the maximum speed that we'd be able to transfer is going to be 10 gigabits per second. That's essentially limited by the port speed that we have, which is pretty fast anyway. 10 gigabits per second is nothing to be ashamed of, and that's going to be able to take that data from the titration cluster to the storage array as fast as possible.
Yeah, I'm pretty sure that disk drives are probably going to slow that down.
Exactly.
Okay.
So that's all you need to provide, the array. And then what happens in a failure scenario? So we know that we have the data already backed up from the primary cluster to that storage array, which has replicated it to the disaster recovery site, and we have an issue at the primary site, whatever that is, whether it's a physical failure, whether it's a network outage, whether it's a natural disaster, whatever happens, we need to restore that backup.
So I see, and obviously here we didn't show the array blowing up, but we would have considered everything is gone on this site, right?
Yes.
Okay.
Yeah.
So in that point, first thing, you'd be happy to have synced the arrays.
Yes.
That's to start with. Second one is if you are choosing to backup over S3, which is a very valid choice, don't forget to factor in this bandwidth in your DR site. That's very, very important, especially if you're using Direct Connect. Make sure Direct Connect is sized appropriately.
Yep. So
kaboom.
Boom. Everything's gone. What's going to happen? Well, the backup site can start restoring from the storage array. So the first thing it's going to do is bring the cluster up. It's going to bring the cluster up with the same version of software that was running on the primary site.
Okay.
Obviously, if you're going to do a stateful restore, you want to make sure that the cluster is running on the same version.
That's better.
This could, the backup site might have been sitting dormant for a while. You might be running an older version of software or whatever was shipped with that initial version of that backup site. And the restoration process is actually going to walk you through upgrading that cluster.
Should we plan from, let's say, eyes and hands on site that any restoration should include a re-imaging of the cluster, just to be sure?
Yes, and it does. So it will re-image the cluster fresh, it's totally blank, nothing is there on that cluster, and then it's going to start bringing some of the configuration back. So one of the first pieces of configuration that comes back is the networking.
Okay.
Obviously, if anything wants to connect to that titration cluster, it has to be network accessible.
That's better.
Yes. Now, by default, the network configuration that will come back is exactly the same as the primary site. That keeps things simple, and it means that you just have to ensure that your routing will point traffic towards that backup. That is one option. However, you do also have the capability to change the network configuration as you bring up that backup site. So let's say, for example, that you didn't have the capability to change your routing to point towards that backup site. You can redeploy that backup cluster in a different network subnet. Now, the reason that that is possible is because when you enable data backup and restore, the software agents move to a DNS-based method of connecting to the titration cluster. So they will search for the DNS hostname of that titration cluster and resolve it to the appropriate network address. That means there's a couple of things to pay attention to. First and foremostly, those software agents obviously need to have a correctly configured DNS resolver. And that DNS resolver should be able to resolve the DNS record of your titration cluster. And you should also have the TTL of that record set to something reasonably short so that when they requery and during that backup system happening, it will pick up the right titration cluster. Anything else there?
I think you covered everything there.
Yeah, and that's all going to be shown to you in the titration user interface. As soon as you enable data backup and restore, it's going to walk you through the fact that we've enabled DNS-based location of the cluster, and it will even warn you if there are particular software agents that don't have the DNS appropriate settings configured.
Very good, Tim.
So we have the network configuration set up. It could be the same addresses, it could be different addresses, and it's going to start bringing that up as fast as possible.
Okay.
So we bring
what happens now?
The cluster up, and then it's going to initiate that data restoration. So it's going to start pulling from that storage array the appropriate data. So we can see that it's going to bring back the sensor data and the certificates first.
Okay.
Why is that important?
Well, I'm guessing we want to get the data, the sensors back online as soon as possible, right?
Yeah. Yeah.
So getting those first of all, I mean, I don't see it as a lot of volume in terms of data. We're talking maybe a few hundred megs, so it's really, really small. So getting that part up is actually super speedy on the platform. And honestly, if you're in a kind of DR, what are the chances that you really want to run ADM now? Close to zero, right?
Yeah, I think there's probably bigger things to be dealing with.
Absolutely.
But that actually leads me to a question, which is, what are those sensors going to be during the time that we're doing this restoration? Are they going haywire?
Look, I mean, they're headless chickens, right? So they run everywhere. No, it's much more basic than that. They will keep their last known state and continue staying in that state until they reconnect to a cluster.
So they will just continue on business as usual, enforcing the policy in exactly the same way that they were enforcing the policy.
Exactly.
It's like if you have a switch that is controlled by a controller and the controller goes down, the switch is still going to continue switching packets. It just won't receive any new configuration. And it's the same for the software agents.
Yeah. Makes me think of the non-stop forwarding and all that stuff.
Yeah, all of those fun things. So we get the sensor data and the certificates back first, so that we keep the secure communication between those workloads, but we don't deal with having to switch out any certificates. And then the policy is going to flow back into the system. Policy allowing us to start looking at the actual applications that we're enforcing and potentially, if necessary, make any changes to those policies.
I mean, that makes sense. At least you can make some speedy changes to policy.
Yeah.
Temporarily, at least, while thing is coming up. I still wouldn't expect you to play around with ADM during DR.
Yeah, you wouldn't want to be doing application dependency mapping, but let's say that there was, some critical policy that you wanted to enforce, like, I don't know, during this disaster, allow more things to speak to the backup servers. Those kind of things could be pushed down as a global policy very quickly. And in fact, during that situation where you're panicking, being able to control policy from a central point of view might actually reduce some of that stress.
Sounds good.
And then finally, once the policy is up and running, at that point, we'll start bringing back the data lake.
That sounds long, just by the name.
Yeah, data lake sounds like it's a big lake of data, and it truly is. It could be hundreds of terabytes worth of data. So that's why we're going to start restoring that data lake slowly over time, but it's not critical to the operation of the cluster. This is just going to give you that same historical data that you used to have in the past.
Okay. Pretty straightforward. So step one, set up your backup array. Set up on the primary site. Step two, make sure you can back up from the titration cluster to the array on the primary site. Step three, make sure the arrays are actually synced together. Step four, if ever, and hopefully never will happen, but if ever you have to restore your backup, bring up a new cluster from scratch. So with the same version as the primary site, IPs can get changed if needed on the platform. Then start the download process. Download process will go in priority, so then you can start getting some form of control pretty fast.
Yep.
Okay. Simple.
Simple. So, what else do we need to look at? Nothing.
I think that's it.
Yeah.
I mean, the cluster is back online.
Yeah.
Or maybe one scenario. What happens if I want to bring my cluster back to my primary site? I just do the same process reversed?
Yeah, just do exactly the same process reversed.
Okay.
Yeah. So even during the most critical situations where we're worrying about clusters going down, we have a pretty simple process to get that data back onto a working cluster. So with that, thank you for joining us on this session on data backup and restore. I hope you found that information useful, but I also hope you never actually have to use it in anger. And if you'd like more information about titration, please visit cisco.com/go/titration.